Hi everybody. Today we're going to do lesson 6.6, which is called geometric sequences. So let's take a look down here. In a geometric sequence, the ratio between each pair of consecutive terms is the same. This ratio is called the common ratio, and each term is found by multiplying the previous term by the common ratio. So a sequence is when you just have a list of numbers and there's a pattern between the numbers. This new pattern here that we're learning is a geometric sequence because we're multiplying by a constant amount every time, and that goes along with the exponential functions that we've been learning in this unit. Just want to do a quick reminder. Remember back in section 4.6, we learned about arithmetic sequences, and in an arithmetic sequence, the difference between each pair of consecutive terms is the same. The difference was called the common difference because each term is found by adding the common difference to the previous term. So look at the pattern down here. You're adding by a common difference to get to the next term. That's for arithmetic, and that goes along with a linear function. So again, to go back to our geometric functions or our geometric sequence, we are multiplying by the same number every time. So let's take a look at example 1. We're going to decide whether the sequence is arithmetic, geometric, or neither, and then explain. Let's look at part A. The numbers are 120, 60, 30, 15. We can see that the pattern here is we are multiplying each term by 1/2. I know some people like to think about dividing, but we are not dividing. We want to think about multiplying to get to the next term. So instead of dividing by 2, that's the same thing as saying multiplying by 1/2. So because we are multiplying by a constant amount, a common ratio of 1/2, this is a geometric sequence. Let's look at letter B. It goes 2, 6, 11, 17. So if I look at the numbers to get from each one to the next one, well, 2 to 6 is plus 4, 6 to 11 is plus 5, then 11 to 17, that's plus 6. There is no common difference here, and we're definitely not multiplying either. To get from 2 to 6 is times 3, but 6 times 3 would be 18. So this is neither geometric nor arithmetic. Let's go down here to example 2. This is extending geometric sequences. We're going to use the fact that we know it's a geometric sequence and find the next 3 terms. So basically, we want to figure out what are we multiplying by and just keep the pattern going. So we have 3, 6, 12, 24. They organize their information in a pattern here, and we're noticing that we're multiplying by 2 every time. So to get to the next term, 24 times 2 is 48. 48 times 2 is 96. 96 times 2 is 192. So those are the next 3 terms, 48, 96, 192. You don't have to make this table, but they found it easier to organize their information that way. Let's take a look at B. We have 64, negative 16, positive 4, negative 1. So it's important to notice here that the signs are changing. If the signs are changing from positive to negative, we must be multiplying by a negative number. Also, the numbers are getting smaller, so we must be multiplying by a fraction. So to get from 64 to negative 116, we're multiplying by negative 1/4. Again, multiplying, not dividing by negative 4. We're multiplying by negative 1/4. And then the pattern keeps going. Let's continue to multiply by negative 1/4. Negative 1 times negative 1/4 is positive 1/4. Times negative 1/4 is negative 1 over 16. Times negative 1/4 is 1 over 64. And those are the next 3 terms, 1/4, negative 1 over 16, and 1 over 64. If you wanted, you could write them as a decimal, and that would be fine. But as a fraction, it's easy to write your answer like that too.